solve the differential equation dy by dx minus 3y equals 7, given that x equals 0 when y equals 0. I'm going to ask you to pause the video, write the question down, go ahead and solve it. Let me just rewrite this here. It says dy by dx minus 3y equals 7. So go ahead and solve it. Okay, what did you get? Now, I had done some work on it previously, and my answer that I got was y equals 16 over 3 e to the 3x minus 7 over 3. So, if you work through it carefully, that's what you should get if I did not make any mistake. Is that what you got? Alright, now I'm gonna let's look at the question. Here, you cannot solve it by direct integration nor by separating the variables from what I'm seeing here. But if you look at it, this is in the form dy by dx plus py equals q, which you can solve by using an integrating factor. Alright? Now in this case, first of all, remember the integrating factor is e to the integral of p dx. That's the integrating factor. Let's identify what we have here. Here, p is negative 3, not 3, because this could be written as plus negative 3y. Alright? Q is 7. Now the integrating factor is e to the integral of negative 3 dx, which works out to be e to the negative 3x. Okay. Now, that's the situation here. What are you going to do next? Multiply both sides by the integrating factor. So you have e to the negative 3x dy by dx plus negative 3 e to the negative 3x y equals 7 e to the negative 3x. Alright? Oh, what did I write up here? My. Negative 3x. Okay, 7e to the negative 3x. Good. The next thing is you look at it and apply the differentiation, the product rule. You apply the product rule but in reverse, right? Or reverse product rule. You're going to say, remember what the product rule said? If you have the derivative with respect to x of u and v, where u and v are functions of x, the derivative is you hold u as it is times differentiate v with respect to x plus you hold v times differentiate u with respect to x. Sometimes you can just write it as d of uv is u dv plus v du. Now, that's what you would have had if you apply the product rule. But we're going this way now. What was it that you differentiated to get this? Here, you hold U, differentiate V. Here, it seems like you hold e to the 3x and differentiate times differentiate y. When you differentiate y with respect to x, you get dy by dx. So this is suggesting that it was y times e to the 3x. Let's look over here now. Here you differentiated y, here you hold y. You held e to the 3x here, differentiate e to the, no, you held e to the negative 3x here. You differentiate e to the negative 3x. When you differentiate e to the negative 3x, you do get negative 3 e to the negative 3x. So, the product that we have is y is one of them. This because you differentiate y here and you hold y here. And then here you differentiate e to the negative 3x and here you hold e to the negative 3x. So the next part of it is e to the negative 3x. Okay, so you have to reason it out like that. What you did was differentiate this. So you did a d by dx of this. Alright? Is equal to 7e to the negative 3x. Alright. Now, what you do next, you integrate. That will free up the y. Alright? Integration will remove the differentiation and leave this free. So you're going to integrate both sides. So you have the integral of d by dx of y e to the negative 3x is equal to the integral of 7 e to the negative 3x. Oh, dx. You want to know when integrating what is the variable here? Is dx. But remember, y is not just a letter, you know. It's not a constant. Y is representing a function of x. Alright? And this dx. Okay, in this case, it's a number 7. Now, if you had an a here, or a b or c, and so on, that would be a function. But remember, in this case, y is not. No, if you had an a, b, c, d, and so other letters, it would be a constant, just a number. But in this case, you have y, it's not just a number, right? Because you had the y and y up here is a function of x. Now, when you integrate with respect to x and differentiate with respect to x at the same time, the integration and differentiation, they cancel out each other, leaving the function untouched, undisturbed. So y e to negative 3x, right, it leaves it unchanged. It remains as it is. Now, this is equal to, alright, I could have even put the 7 over here, but let me just leave it as it is. When you integrate e to negative 3x, you're integrating a function of a function, where the inside function is negative 3x and the outside function is e to the power of that. Now, if you've been doing a lot of practice in integrating using substitution, which is what you do when you integrate a function of a function, then you could very well do it mentally, right? But let me assume you have not been doing that. So let's look at this. Let me put the 7 outside the integral sign now. Now, here we're going to use integration by substitution. So, alright, let's just integrate e to the negative 3x dx. And remember that this 7 was there, don't forget it. Just that we're not putting it here now. Alright. Let u be equal to negative 3x. When I write it up there, equal to negative 3x. Alright. So what you have is the integral. Remember, this is the fixing up the substitution. Here, what you're doing is finding the integral of e to the u. Alright. But this says dx. We want du. So du by dx is negative 3. So what is dx? When you transpose this to make dx a subject, what you're going to have is that dx is equal to du over negative 3. Alright? So what you really have here is the integral of e to the u dx, which is du over negative 3, which is negative 1/3 integral of e to the u du. Alright? Now, when you integrate e to the u with respect to u, what you get is e to the u plus c. Alright? So that's what you really get. So here, let's get back to this. Y e to the negative 3x equals y e to the negative 3x equals it's going to be 7 times the integral of e to the negative 3x. So it's going to be 7 multiplied by, you could put this here, by negative 1/3 integral of e to the u du, which is, oh, I worked it out already. Alright, let's, you know what, the integration was worked out, so let me put it times negative 1/3 e to the u plus c. But what was u? U, you need to change it back to x. U was negative 3x. So it's e to the negative 3x plus c. Now that would be negative 7 over 3 e to the negative 3x plus 7c. Alright, 7c would be a different constant, so we could call it d, but I want c to be there. So you see this, what I had originally as c, let's call it c1, and then when I multiply c1 by 7, I call it c, different constant. I like using c instead of some other letter, or c1, c2, and so on and so forth. Nothing wrong with that, but I just like it to keep it as c. Y e to the negative 3x is equal to, so that's negative 7 over 3 e to the negative 3x plus c. After that, you divide both sides. To get y equal, you divide both sides by e to the negative 3x. So y equals, because e to the negative 3x will cancel itself when I put it under here. Y equals negative 7 over 3 e to the negative 3x over e to the negative 3x plus c over e to the negative 3x. This will cancel itself. So y equals negative 7 over 3 plus, and then you have, it's the same, this would be the same as C e to the 3x, right? CE to the 3x. Now the thing is, that's the general solution. This is the general solution. If you were not given an initial condition, you would just stop there with the general solution. But what you're told is that x equals 0 when y is 3. Or y, what is it? X is 0 when y is 3. Given that x is 0, well, it's x that changes and y follows it. So maybe it should be that y equals 3 when x is 0. Yeah. I think that should be the wording of it. So y is 3 when x is 0. X is the independent variable here. Y depends on x. So it's after x becomes 0. After x is 0, what happened to y? So y is 3 when x is 0. Alright. So y is 3. 3 is equal to negative 7 over 3 plus c e to the 3 times 0. We run out of scrolling space, you know. Can't scroll down anymore. Just draw a line upwards and work on the right hand side of that line. So what we have, 3 is equal to negative 7 over 3 plus, so 3 equals negative 7 over 3 plus c e to the 0. C e to the 0, but e to the 0 is 1. So you can say c plus, alright, let's see now, 3 equals negative 7/3 plus c. If you add 7/3 to both sides, you're going to get 3 plus 7/3 equals c. So c is, you have to do some fractions now. So it's 3 over 1 plus 7 over 3. Let's get common denominators. Multiply this by 3, multiply this by 3. You get is 3 3s 9 over 3 1s 3 plus 7 over 3. 9 and 7 16. So c is 16/3. So what you have then is y equals negative 7 over 3 plus, oh boy, plus c e to the 3x. So that would be 16 over 3 e to the 3x. Is that the answer that I gave? Negative 7 over 3 plus 16 over 3 e to the 3x. Negative 7 over 3 plus 16 over 3 e to the 3x. Okay, just I'll put the positive part first. So you could rewrite it as y equals 16 over 3 e to the 3x minus 7 over 3, 7/3. So okay, good. So that is our particular solution.